A 180-ton machine costing over $200 million consumes electricity like a small town, all to hunt a single target. Molten tin. It sounds like a failed science fiction project. But, in reality, this is the heart of every phone you've ever touched. Chips are not carved with blades. They are bombarded by extreme ultraviolet light EUV in a vacuum environment. The challenge? You must hit a droplet of tin flying at 250 kilometers per hour, twice in a row, 50,000 times per second. And a single speck of dust, smaller than a skin cell, can turn a billion-dollar production line into very expensive decoration. Welcome to Everyday Things Explained. The execution of molten tin. You might think light is something you get by flipping a switch. But for ASML, light must be created in the most violent way possible. They don't use bulbs. They use high-power carbon dioxide lasers fired at micrometer-sized droplets of molten tin. The first shot flattens the droplet. The second shot turns it into plasma, hotter than the surface of the sun. That is when EUV light is born. Physically, EUV wavelengths are so short, they do not pass through matter. They are absorbed almost instantly. Air absorbs it. Glass absorbs it. Even common materials swallow it like air swallows sound. This is the inevitable result of using extremely high-energy light. And this is where things become uncomfortable. You have just created a form of light, but have no way to contain it. The hell of mirrors. You cannot use lenses. Because EUV would be absorbed by glass before it even begins to work. The solution? Mirrors. But not the kind you hang in a bathroom. These mirrors are polished to such perfection that if scaled to the size of Germany, the maximum deviation would be about 1 millimeter. That is not smooth. That is perfection at the atomic level. Each mirror consists of dozens of material layers stacked with near absolute precision. Each time it hits a mirror, it loses some energy. So the entire system must be designed for light to die as slowly as possible. A tiny deviation equivalent to the width of a hair over the distance from Earth to the Moon is enough to ruin the entire chip. You are not building a printer. You are controlling light at the atomic scale. But even if you master light, it still has an enemy. Air. The vacuum tomb. EUV does not like air. It treats air like an invisible wall and disappears the moment it touches it. The only solution: remove the air. The entire system operates in a near-perfect vacuum. No oxygen. No dust. No life. Physically, you are creating a space where light can exist long enough to complete its task. But that comes at a cost. Everything inside must be extremely clean. A single dust particle smaller than a bacterium can distort the path of light, and when light deviates, a 2-nanometer transistor becomes a manufacturing defect. No warning. No explosion. Just a dead chip. This is no longer engineering. This is the management of physics at a ruthless level. The Geopolitical Noose. You might think ASML is just a company, but in reality, it behaves more like an ecosystem. More than 5,000 suppliers contribute to a single machine. Germany provides ultra-precise mirrors. The United States provides the laser source. Japan provides chemicals so pure, they are nearly free of impurities. None of them can do it alone. This is the inevitable result of technology reaching physical limits. You cannot shortcut this with money. You cannot copy it from blueprints. Even with unlimited budget, it would still take decades to recreate this ecosystem. And that is why ASML has become a bottleneck of the modern world. You think you are holding a smartphone, but in reality, you are holding the result of a fragile global dependency chain. The Timekeeper of Civilization. The entire modern digital economy depends on beams of light created from vaporized tin droplets. Inside airless rooms in the Netherlands. No EUV, no advanced chips, no AI, no smartphones, no most of the world you rely on. A single machine, keeping the rhythm of an entire economy. It sounds unstable, and it is. If it stops, there is no Hollywood effect. No explosion. Just everything slowing down, then stopping completely. We have just looked at the most sophisticated machine ever built, a system controlling light, matter, and vacuum all at once. But the truth is, it was never designed to last forever. It was built to push the limits just a little further. And while you are holding a compact device in your hand, somewhere, molten tin droplets are still being executed 50,000 times per second to keep the world running. A production line powered by pure physics. And if you think that is the peak, the aircraft black box is designed to survive disasters that even this machine would rather never witness.